So today we're going to look at some examples of calculus. We're going to look at examples of my favourite kind of calculus, which is calculus of trigonometric functions. So what happens if we need to integrate a trigonometric function but we can't see immediately how to do that? Well, we can try and use the trigonometric identities that we know to manipulate that function until we can integrate it. So let's take a look at the first example. We've got the integral of cos 2x times cos x. How do you think we might be able to integrate this? The product rule is a good idea, so try it at home and see where you get. You might find you get quite stuck. So another idea is to look at the trigonometric identities that include the product cos A times cos B. So we're going to take a look at some trigonometric identities that can be used for this question and questions like this. So these are the compound angle formula for sine and for cosine. Here we have cos A times cos B in both these identities. So what now? Well, if we add these two identities together, then we get another identity which cancels out the sine A sine B term. Then we can rearrange this to get the product cos A cos B in terms of a sum of cosines. So this helps because we know how to integrate cosines when they're on their own. So now, to apply it to our question, let's input the values for A and B. We substitute in A equals 2x and B equals x. We can then put this back into our integral and integrate easily, because cos 3x integrates to a third sine 3x and cos x integrates to sine x. Remember the plus c at the end. The next example is the integral of 5 sine squared 7x. How can we solve this one? So how do you think she got that answer then? Okay, I see. Unfortunately, it's not that simple though. So we need to look at trig identities that include the term sine squared a. Combining the first two, we get the third. And this is the identity we want. We can then rearrange it and we have it in the form of something that we do know how to integrate, which is a half of 1 minus cos 2a. So what now? Well, as before, we just have to input our value of a, which in this case is a equals 7x, and then we can use it in our integral. So putting it back in our integral and taking the 5/2 out the front, we can then integrate to get our answer. Pause and check that you can see how we got the answer. So now the final example, this time between limits. It looks quite difficult, but it's all about breaking it up into different bits. Great, integration by substitution is a really good way to tackle this problem. You can also do it using integration by recognition. All you need to do is recognise that sine squared 3x is a third of the differential of tan 3x. Don't worry if you haven't seen this method before though. Okay, so what will my substitution be? We need to pick something simple. So I'm going to pick u equals tan 3x. First thing to do is work out what the differential of our substitution is. We can then rearrange this to get du in terms of dx so we can put it into our integral. I'm just going to write the integral like this so you can see where the substitution goes in. So we've now got 2 times the integral of u to the power 7 times a third du. Finally, you must remember to change the limits of the integral. So when x is 0, u equals tan of 3 times 0, which is 0. When x is pi over 4, u equals tan of 3 times pi over 4, which is minus 1. We can now finally complete our integral. We put in our bounds and we get the final answer of 1 over 12. Now hopefully you have the tools to complete lots of different trig integrals.